Hey, good morning, everyone. Today we're going to look at the free body diagram practice. So this is the assignment that we're going to be working on over the next couple days. So this is going to be for Thursday and Friday of this week. So these ones are pretty simple. We're going to be practicing what we've done before. So there's a link that's included here, which will take us to our simulation. Our goal is to complete all 12 situations, and we're going to do one example one together. We're going to read each situation and fill in the forces by selecting the direction first, then picking the type of force. To make it bigger, you're going to click on the arrow. So this is one common problem that we're going to see is we need to click on the arrow to make them larger if one force is greater. To check your answer, you can try again if you don't get it correct, and then you're going to take a screenshot when you're finished. So let's go ahead and take a look at the first one. So these situations are in random order. So the first one is going to be ours here. So we're looking at a downward moving skydiver who just opened a parachute and is slowing down. So first force that we want to look at is we're going to hit down, and this will give us some options. So if we're talking about a skydiver, we know the skydiver is going to fall to the ground due to gravity. So we hit gravity, and gravity is now pointing down. Our second force that's acting on the skydiver is going to go up. So the parachute itself is going to provide air resistance. So when it opens up, it's going to catch the air and slow him down. So we have gravity and we have air resistance. So here, if we hit check, we're going to see something where it says it's not correct. So what we have to consider, right, if the guy is slowing down, then we should have more force pushing up than down. Because if they were balanced, it would be the same. So we want a larger force for air than we do gravity. So if we check now, we got this correct. So for here, we're going to take a screenshot of this, and we can put this into our slides. So under situation 1, we can put our example, Control V, and place it in. There we go. So that's something to consider. When we look at these forces, we want to make sure that we account for which one's greater, which one's smaller. So here's a couple notes for us to remember as we're going through this. If the object's accelerating or decelerating, so if it's speeding up or slowing down, the forces are unbalanced, so there has to be a net force. So as a result, one of the arrows has to be bigger than the other. So if the object's changing speed, the arrows have to be different sizes. If the speed's constant, staying the same, they're going to be balanced. So we need to change the size of the arrows for unbalanced forces. If the forces are balanced, they're the same, we can have the same size arrows. So hopefully this is something useful for you guys getting started on this. If you get stuck on any situation, skip it and go to the next one.